Good afternoon. Today is Wednesday, April 8th, and we are on the 8th of our online skills. And we are going to be covering Geometry IXL Skill B6. That has to do with perpendicular bisectors, and so you will be able to apply the perpendicular bisector theorem to find the measure of line segments. And this is the theorem. The perpendicular bisector theorem states that a point is on the perpendicular bisector of a segment if and only if it is equidistant from the endpoints of the segment. So here you have x, which is a perpendicular bisector. X, which is a point on what is a perpendicular line. The line is right angle. That's why we know it's perpendicular. We know that that line is equidistant from W and Y, so it is a perpendicular bisector. So that means that this point is equidistant between the two, and that means that WX and XY are equal measures. So we would say that X is on the perpendicular bisector of WY if and only if WX is congruent to WY, which it is here. Okay. I want to remind you again that your minimum score is 65 points. Or I'm sorry, 85 points, pardon me. Minimum score 85 points. We are going to continue that. And also I want to remind you we're doing online work, and because we're doing online work, you need to do your work on this piece of paper. This piece of paper, it can be either a grid paper like you see here, or it can be blank paper like you see on the back. It's encased in a plastic sheet, and you would be using an Expo dry erase marker to do your answer, and then when you're done, of course, you can erase that with just a plain old rag, piece of shirt rag, and you're taken care of. If you don't do this, and you do not use this graphing calculator or any scientific calculator to do your work, as you go through these problems, many of you now know that they get progressively harder, and it becomes difficult, if not impossible, to get to 85 unless you use these two tools. Make sure you're using them. Graphing calculator and the plastic covered sheet. All right. So we're now going to look at example 1. And in example 1, we have what appears to be a line segment EG, and it has a perpendicular line running through it, FH, and the example says if EH, and EH is this portion of the line segment, is congruent to GH, and EF equals 74, what is the measure of FG? That is what they're asking for. So to answer that question, first of all, what you're going to want to do is you want to go ahead and label the diagram with the information in the question. So I'm just going to write that. Label the diagram with the information in the question. Okay, and so since we know that angle, this would be FHG, it's this angle right here, is a right angle because they tell us that. I'm going to write that down. Since angle FHG is a right angle, we're going to go into, again, the the theorem for perpendicular bisectors. So we're going to say, and also, and EH is congruent to GH. That's these two sections here. And let me go back and do what I should have done before, is label the diagram to make it easier for you to see that, because we said up here, label the diagram with the information in the question. And so we know EH is here, GH is here, and then we know EF he is here, so here's the 74. So we know that EH is congruent to GH, and FH is the perpendicular bisector. Of EG. That's the whole thing. So this is a bisector, and we know it's a bisector because it separates the whole line into two sections that are congruent, EH and GH, and it's perpendicular because of the right angle. So FG, that's this line segment here, will have to equal EF because of this theorem. Because if you remember, going back to the theorem, they said that, look, if you find out that this is a perpendicular bisector, then the distance from this point to E and this point to G has to be the same measure. So that's going to equal 74 units. This is 74, this is going to be 74. And you're done with it. Okay? All right. So I'm going to take you to another problem that is common and shows up in the towards the end, where you have slightly more complicated problems. So here you have a similar geometric figure, but notice, let's see, WT is congruent to TU, but VW equals 4y and VU equals y plus 42. So obviously they want you to do something different here. Okay, so as far as labeling the diagram is concerned, looking at this, on my other page here, you know, all the information that you see is actually already in the diagram. So we're just going to say that. So note, all of the information is in the diagram. Okay, and since angle VTU here is a right angle, we'll write that. Since angle VTU is a right angle, again repeating the perpendicular bisector theorem, and UT is congruent to VT, I'm sorry, TW. So UT is congruent to TW. All right. Then VT, that's this line here, so I'll show it as a line, is the perpendicular bisector. and it's the perpendicular bisector of WU, but we also know it is in the middle here because we said that in the perpendicular bisector theorem. If you remember going back to the theorem itself, the theorem said that a point is on the perpendicular bisector, in this case point X, if and only if it is equidistant from the endpoints of the segment, which it is, and this is the distance. And so the same thing's happening here. V here is the point. So V is the point equidistant from the endpoints U and W. So as a result, we've got this equidistance here. Now, if you wanted to, you could talk about the fact that you created two triangles here, VTW and VTU, that are congruent because they have a side here, VT, line segment VT is congruent to itself, reflexive property. You've got side WT and side TU that are congruent because it says so, and you've got a right angle here for both of these because it says so. Therefore, due to side angle side, you have congruency of these two triangles, and congruent parts of congruent triangles are congruent. Therefore, again, VW is congruent to VU. So, but this is sufficient, what we just said here. So, VW is equal, why don't we take this off and just use algebra, equal to VU, okay? Remember, when we're using algebra, we don't use the little geometric symbols. Algebra we're using because we have an equal sign here. And so then substituting, we're going to substitute for VW here for Y. And Y plus 42 for VU. For Y then equals Y plus 42. All right? And so now you're going to undo. And so we're going to subtract Y from both sides. So I'll subtract Y over here. Let's use a little different color. Minus Y, and so I get 3Y equals 42, and then I'm going to divide both sides by 3. And of course, when I do that, okay, maybe I'm a little shy and I need to sit down with my trusty calculator to be sure. Let's take 42. I'm going to take and punch in 42 here. Oops, first I got to turn it on. So 42, and I'm going to divide that by 3. And I get 14. So Y equals 14. And that was what we wanted. That's our answer. So we're going to put 14 in here. You plug that in and you hit enter. Okay, so as I said, these problems will get successfully complex or I should say successively more complex, but they fall along the lines of these two examples that you see. So you shouldn't have too much problem with them, and I think you're ready to go. Tomorrow I'm going to be setting up a a Zoom video conferencing meeting, and I'm going to be sending you all an invite to it. I believe we're going to do it. In fact, I know I'm going to set it up for 10:30. 11 o'clock. 11 o'clock in the morning. And when 11 o'clock comes, you will take the link. You will put it into your browser, hit enter, and it'll take you to my Zoom meeting. And at that time, we're going to do two things. One is I'm going to have you, if you don't do it already, I'm going to have you fill out a questionnaire that I have for you in our Clever website concerning your grade, what you're going to want to do for your grade. And I've got some information I'm going to share with you about your grades. And then I'm also going to entertain any questions that you might have. And so we'll do that for an hour. And we're going to do that on Fridays on a regular basis at 11 o'clock. We're doing it tomorrow because Friday is a woohoo holiday. So you actually have the day off. You don't need to go to school, guys. I know that sounds like a bad joke, but it actually is a holiday. So teachers are not theoretically working that day. Although I suspect I probably will be, but I won't be answering emails. So you know what to do. Get started on this, and I don't think you're going to find it too tough, but be sure to use paper and your calculator. Thank you very much. Have a good afternoon.